Here we'll be taking a look at an example of a Hess's law question. So you are given the enthalpy change for a number of reactions, and you are asked to calculate the enthalpy change for a certain reaction, which is 2 carbon plus 3 hydrogen to become an ethane molecule. So as we always say, start with the end in mind. So first of all, draw a line, and at the bottom you write the equation that you want to achieve in the end. Now that we've written the equation that you want to achieve, let's see how we can manipulate the other equations so that we end up with this final equation. So we see that on the left hand side you have 2 carbon graphite. So how do we get 2 carbon graphite? We can use this equation, the equation number 1, but times 2. So let's write this equation but times 2 for the equation. So 2 carbon plus 2 oxygens becomes 2 CO2. So since we multiplied the chemical equation by 2, this means that our enthalpy change will also be multiplied by 2. So enthalpy change for this reaction would be negative 393.5 times 2. And that gives us negative 787 kilojoules. Next, looking at the final equation that we want, we see that we must have ethane C2H6 on the product side. So to get ethane on the product side, we need equation 3 that is given. And equation 3 gives 2 ethane molecules, but we want to have only 1 ethane molecule. So what we need to do with equation 3 is to flip the equation so that ethane is on the product side, and also half the reaction, which means to multiply all the coefficients by half. So let's do that. So switching the products and the reactants, we need to have 2 CO2 because we multiply by half, and 3 H2O on the reactant side, and we switch ethane C2H6 over to the product side, and 7/2 oxygen. Now what happens to the enthalpy change? Since we have flipped the equation, we also need to switch the sign of the enthalpy change. So now let's do negative of negative 3119.6, and since we have also half the reaction, we need to times half. And so we get positive 1559.8 kilojoules. Finally, we want to cancel out all the reactants or products that are not in the final equation. So let's take a look whether there's anything that we can cancel out. Okay, we see that 2 CO2 is produced by the first equation, and it is used up by the last equation, so we can cancel carbon dioxide. We do have some oxygens, but they don't totally cancel each other out. We can also see that there's 3 H2O on the reactant side. Okay, so to cancel out the 3 H2O, we will need 3 H2O on the product side, and we can add 3 H2O using equation 2. So for equation 2, there is 1 mole of H2O on the product side, so we need to multiply this chemical equation by 3. So writing this down, 3H2 plus 3/2 O2 to get 3H2O. And for enthalpy change, Since we have multiplied this equation by 3, enthalpy change also will be multiplied by 3. So that's negative 285.8 times 3. And we will get negative 857.4 kilojoules. So now let's cancel out the remaining reactants and products. So for equation 2, 3H2O is produced, but this 3H2O is used up in the third equation. From equations 1 and 2, you have 7/2 oxygens which are used up, and on equation 3, there's 7/2 oxygens that's produced, so they cancel each other out. And now let's check the remaining reactants and products. On the reactant side, we have 2 carbon, we have 3 hydrogen, okay, and on the product side, we have 1 ethane. So we have already arranged the equations correctly to get our final equation. So now all that's left to do is to find out the enthalpy change by adding up all the enthalpy changes of the previous reactions. Okay, so for the enthalpy change of our final reaction, it would be negative 787 plus negative 857.4 plus 1559.8. And we should get the final answer of negative 84.6 kilojoules.